Aim: to verify the parallelogram law of forces, the triangle law of forces, and to find the relative density of the given stone. Apparatus: drawing board with 2 fixed pulleys, 3 sets of hanger weights, twine thread, protractor, set squares, and drawing pins. Here you can see 2 pulleys A and B are fixed to a wooden board. 2 weight hangers P and Q are attached by a string and passed over the pulleys A and B. A third weight hanger R is attached at a midpoint O of the string. The point O will be in the equilibrium under the action of 3 forces P, Q and R. Here, P, Q and R are 3 coplanar forces on X, Y and Z acting at point O. Let us consider a scale of 25 gram is equal to 1 centimeter. Therefore, OA is equal to OB is equal to 100 gram, which is 4 centimeters. OD is equal to 150 gram, which is 6 centimeters. Draw the arcs from point O on all 3 forces P, Q and R with its corresponding values. Mark them as A, B and D. Now, construct a parallelogram by drawing 2 more arcs from A and B so that they meet at point C. Here, AC is equal to BC, which is 4 centimeters. Join OC and measure its length. Here, OC is equal to OD, which is 6 centimeters, and angle COD is equal to 180 degrees. Hence, parallelogram law of forces is verified. Here, P, Q and R are 3 coplanar forces acting at point O. By drawing lines parallel to the forces OP, OQ and OR, a triangle ABC is formed. The sides of the triangle ABC, which is P, Q and R, represent the forces OP, OQ and OR. Here, the force P is equal to 100 grams, Q is equal to 100 grams and R is equal to 150 grams, and its corresponding lengths of P, Q and R from the formed triangle ABC are P is equal to 2.5 centimeters, Q is equal to 2.5 centimeters, R is equal to 3.7 centimeters. The values of P by P, Q by Q and R by R is equal to 100 by 2.5 is equal to 100 by 2.5 is equal to 150 by 3.7. They are almost similar to 40. Hence, triangle law of forces is verified. The same experiment has been conducted by immersing the stone in a beaker of water. The weight of the stone in water thus obtained is 75 grams. Similarly, using triangle law, the weight of the stone in air and water is determined and all the values are noted down in the observation table. Verification of parallelogram law of forces. Here, the weight of P is 100 grams, Q is 100 grams, R 150 grams, and its corresponding length OA is 4 centimeters, OB 4 centimeters, OD 6 centimeters, and OC 6 centimeters, and its angle COD is 180 degrees. Similarly, the corresponding values for 150 and 200 grams are: using parallelogram law of forces, weight of the stone W is equal to diagonal OR of parallelogram OPRQ into scale. Diagonal OR is equal to 2.9 centimeters. Scale 1 centimeter is equal to 50 grams. Therefore, 2.9 into 50 is equal to 145 grams. Weight of the stone W1 when it is immersed in water is equal to diagonal OR into scale, which is 1.5 into 50, that is equal to 75 grams. Volume of the given stone V is equal to W minus W1 centimeter cube, which is 145 minus 75, that is equal to 70 grams. Relative density or specific gravity of the stone is equal to W by W minus W1, that is equal to 145 divided by 70, which is 2.071. Verification of triangle law. Here, the weight of P is 100 grams, Q 100, R 150, and corresponding the length of AB is 2.5 and BC is 2.5 and CA is 3.7. The value of P by P is 40, Q by Q is 40, and R by R is 40. Similarly, the values for the weight 150 and 200 grams are: according to triangle law of forces, P by small p is equal to W by R. Weight of the stone in air W is equal to P divided by small p into R grams, that is equal to 100 divided by 2.5 into 3.7, which is 145 grams. Weight of the stone when it is immersed in water W1 is equal to capital P by small p into R grams, that is equal to 100 divided by 2.5 into 1.8 grams, which is 75 grams. Volume of the stone V is equal to W minus W1 centimeter cube, that is equal to 145 minus 75, which is 70 grams. Specific gravity or relative density of the stone is equal to W by W minus W1, that is equal to 145 divided by 70, which is 2.071. Precautions. The pulley should be frictionless. The weights should not touch the drawing board. The board should be stable and vertical. While marking the shadows of thread, the weights should not oscillate. The hanger should not touch the board. Arrows should be marked to show the direction of forces.